Hi guys, so today we are going to solve one more important question related to the binary search, and in this question the question says every element occurs twice. Okay, every element occurs twice except for one element. So one element is unique and we have to find out that unique element. So in our case, this element is unique. You can see this 1, 3, 2, 0, 6, 2, 4. These are unique elements. Sorry, these are duplicate elements, or these are elements which are occurring twice. Right. This is what the question says, and we have to find that unique element. This unique element which is occurring only once. Okay. So how you can approach this question is what you can do. You can take two pointers like I and j, and if I equals to j, you can move uh, plus 2i, plus 2 in both. Okay, so I moves two times, that plus 2 times. So I is here, now I becomes here, then j will also become here. So you will again compare. If they are equal, then you will move both I and j to this place, then again to this place, then again to this place. Okay, in that case, which I and j are not equal, you can simply return a of I. This is the brute force you can apply here. But in this case, the time complexity become O of n. Why? Because in the worst case, you have to iterate every element. You have to. So let's say my unique element is here at this place. So your I and j will iterate every element, right? So in this case, the worst case scenario, the time complexity will be O of n. Now there's one more approach you can follow here is XOR approach. Okay, using bitwise operator. So we know that the element, let's say a, or let's say if we multiply x, if we XOR x with x, we have 0, and if we XOR x with 0, we will have x. Okay, so this is the application of XOR. So I will create one more series for bitwise manipulation. Okay, this is bitwise manipulation. I'll create this series, a separate series on this, where you will know the applications, the more applications on the bitwise operator and other operators. Okay. For now, just remember, if we XOR the same elements, then it will give us 0, and if we XOR it with 0, then we will get that element. Okay. So this is the scenario. So if we XOR this element with this element, we will get 0. Okay. Let me, yeah. If we XOR this element to this element, because both are same, okay, we will get 0. If we XOR 0 with 3, we will get 3. If we XOR 0 with 3, we will get, if we XOR 3 with 3, we will get 0, and so on, right? 0, 0, 19, and 19 and 6 will give, okay. So just keep 19 as it is. If we XOR 6 with 6, 0, 2 with 2, 0, 4 with 4, 0, 1 with 1, 0, 0, 0, 0, and everything is 0, and if we dot 0 with 19, will be 19. So my last answer will be 19, and it is returned. Okay, it will handled by JVM automatically. So once um, we will revise this concept, we'll go through this concept, you will know how this jar works. Okay, again, the time complexity of this question will be O of n using XOR, because at the worst case you have to iterate every element till the last, right? And in XOR you have to iterate every element till the end, whether if you are finding it here or here or here. Okay, so every time the XOR will return the time complexity O of n. Now, uh, is there any other approach? Okay, we have seen the linear search where we have iterated every element, right? Now let's think about this. Can we can we apply binary search here? Can we apply? Let's think about it. As you can see, this array is not sorted. Okay, this array, let me copy this. This array is not sorted. So just think about it. Can we apply binary search here? We can. Why? Because we are studying the binary search, right? Yes. But can you see any pattern here? Can you see the elements before the unique element and the elements after the unique element? Can you see any pattern? Okay. What I can see is the elements which are before the unique elements, the just just check about these duplicate elements. These are starting from the even number ending at the odd number, right? And after the unique element, you can see this is starting from the odd and ending at the even. See the difference? Okay. So check once again. Before 19, we have starting of the element is 0, starting of the element is 2, starting of the element is 4, starting of the element is 6. Okay. So starting is even. Before unique, first occurrence is even. Okay. And after unique, first occurrence is odd. You can see here, right? Using these observations, we can solve our question. Okay. Yeah. So let's do a dry run for binary search. There we can actually see how we can solve it. Okay. So for binary search, we have L, we have H, low and high, and we have mid. We will find out the mid element. Then we will check, is this any element unique? Okay. And then we will check the first occurrence. Okay. Why we are finding the first occurrence? Because let's see, before the unique element, the first occurrence will be even, right? And after the unique element, the first occurrence will be odd. So if we find the first occurrence, let's say we find this first, this is odd, then we can say that we have to look on the left side because my unique element will present on the left side. And if let's say my first occurrence is even, then my unique element will present at the right side. Do you agree this? Right? Just think about it. Let's say, let me give you one more example. 1, 1, 2, 2, 3. Let's say 1, 1, 2, 3, 3, and 4, 4. Okay. What is the index? 0, 1, 2, 3, 4, 5, and 6. So before the unique element, we have index at even, and after the unique element, the first occurrence is odd. Index of the first occurrence is odd. So if somehow if we landed here, and if we say the first occurrence is odd, then we can conclude that my unique element will present at the left side. Right? This is what we are going to do. We are we are just updating our search space on the basis of this index position. Okay. So let's say let's try it on this. You will know how it works. So my L is 0 and my H is at this place right now, which is 14, and the mid value will be 7. Now I'll check, is it a unique condition? So this is the happy case. What is the happy case? If we are at the middle, so my M is 7, here it is my M. So is this the unique element? How you can check this? You can check this if A of middle element is not equals to A of its previous element, and A of middle element is also not equals to the A of m plus 1. That means its next element, right? So in this case, is it unique? No, it is not. It is not. Then what is the first occurrence? We will check. What is the first? We will check the condition. Let's say if we checked, how you can check it. If it is not unique, so that in that case, either its first occurrence is even or odd. Okay. So this element, we will check if A of m is equals to the A of m minus 1. If it is equal its previous value, that means this is we have landed at the second index of the same element, right? Right? Okay. So in that case, what we will do, we will say just move m to the previous place. So now I moved m here. Okay. So my m is here now. Now this is at the first index. Got the point? So this is here at the even index, and because we have now we are in at the even index here. So my unique element will present on the right side. So I will update my L to m plus 1. Okay, m plus 1. Okay. Now, one update here is if we do m plus 1, my m will again come to this place. L would come again to this place. But this is all, this we have already done. We have already landed m here. So we are not going to land it here. So we are going to do m plus 2 here. Okay. So my L is 8, and my H is still the same, and the mid value will be 11. So I'll check. I landed here. I'll check. I'll check. Are they unique? Is it unique? No, it is not unique. So what I can do, I'll check. If my this element which where I have landed is equals to the previous element, is it equal to the previous element? No. No. That means this is the first occurrence. This is the first occurrence. And if it is the first occurrence, so this is odd. This M is odd. And it is the first occurrence. That means our unique element present on the left side, right? If it is odd, then the unique element is present at the left side. Then we will go, then we will, my search space will be left side. So my H will landed here before M. Got it? Now, now my L will be same, and this time my H landed here before M. So my middle value is 9. Here I have landed. This is my M here. Okay. Now, is it unique? No, this is not unique. And I will check. My A of M is equals to the previous value. No, it is not equals to the previous value. That means this is where I have already landed. This is the first occurrence. And my first occurrence is odd. If it is odd, then again I am searching to the left side. And this time this remains the same. And this will become 9. And my mid value will become sorry, this will become 8. And minus 1 is 8. And my mid value is 8. And now I'll check my M is here. Is it a unique element? Yes, it is a unique element. We can simply return. We can simply return the answer. Okay. I hope you understand. So let me write the pseudocode here. So mm, let's say You can pause the video and you can write the code, pseudocode by yourself. Okay, I'm writing it right now. So I'll start my L with 0, my H with the last element. And if I don't found my answer, then I will simply return -1. I will start a while loop. And as usual, I'll say my L should be less than equals to the H. I will populate my M, L plus H by 2. I have populated my. Now, my first case is the happy case. If my A of M is not equals to the A of M minus 1, and my A of M is also not equals to the A of M plus 1. Okay, so I'll simply return M. That means this is what? This is the unique element. Now, my second condition, if A of M equals to the A of M minus 1. I'm checking. I'm checking if its previous element is same. That means we have landed on the even index. That means the first occurrence is present at the even index. Okay, this is what it means. This is what it means. So what I'll do M is equals to M minus 1. So I'll move M to the previous place. Now, this time I will check if M mod 2 equals to 0. What I'm checking is if I have moved my M to this place. If it is equals to the previous element, so I have moved M to one place before. So if the M, which is even now, M mod 2 equals to 0, then I will move L to plus 2. Okay. And else if why I'm moving M plus L is equals to plus 2, because if it is landed at the even index, then my unique element will present on the right side. Okay. And else H is equals to M minus 1. If it is not even index, then my first occurrence is landed at the odd index. And then the unique element is present on the left side. Right? We have seen that. Yeah, this is the case. And now simply we can close the while loop and we can simply return the answer. Okay. Yeah, we can simply return the answer here. What is time complexity? Time complexity, because of this reason, the time complexity of log. This is how we reduce the time complexity. Right? Yeah. So there's one improvement in this question. What is the improvement is what we are doing. What happens if my let me write it this way: 2, 2, 3, 3. What happens if my unique element is present at this index? So in this case, my M minus 1, which is, let's say if I landed my M here, so my M minus 1 will become array index out of bound exception, right? So in this case, I have to start my L with N. And the same way, my M plus 1, if my M is landed here, and my M plus 1 will give out array index out of bound. So my H will start at this index, right? So my L is here, H is here. And we have to handle the corner cases. How you can handle the corner cases? You can simply write if my A of 0 is not equals to the A of 1, the next element. If it is not equal to this element, that means this is a unique element. Simply return 0. That means 0 index is unique. And if A of n minus 1, the last element, is not equals to the A of n minus 2, its previous element, then simply return n minus 1. This is the corner. These are the corner cases we have handled, and we have started our loop from 1 to n minus 2. So this is uh, the improvement we have to do while doing this. Okay. Yeah. So that's it for this question. For the next question, I'll come up with a new video. Thanks for watching.